Hello, good afternoon, everyone. This is Neil Roach from Apposite Technologies. Um, I'm going to present the first part of the webinar, Validating Cloud Applications Before Going Live. And after about 15 minutes, of kind of giving you an overview, I'll pass to a colleague, and then we'll actually give you a live demonstration of doing some application testing with WAN emulation. So without further ado, just before we get into details on the topic today, just a couple of words to talk about, what is network emulation versus simulation, since the words are often used, interchangeably. A simulator can perform tasks in abstract, so it's more like a mathematical model to demonstrate the behavior of a network and its components. So it's used, primarily as a theoretical mechanism for academic purposes. And so there's some, quite popular simulator models out there, for doing those exercises. Whereas a network emulator can actually copy the behavior of a network to, functionally replace it, and then you can do some kind of valuable performance testing, for the real world network. So before we get into more details on the application testing, just a few words about Apposite Technologies and who we are. Apposite is actually the market leader in network emulation for pre-production testing of applications over the wide area networks. We're based in Los Angeles. We have about over 2,500 customers, and we work for the UK. We work with Open Reality because they're specialists in network performance testing, both supplying products and also professional services. The people who use our products are a mix of large enterprise customers, public sector, developers of equipment and applications across the board. So nearly every leading system developer uses our products, and then we also help government agencies as well, and telecom operators. So this is the last commercial slide before we go into the technical details. So what makes us different? What the customers say, is really easy to use these products and doesn't require any training. So folks who are doing IT projects, moving applications, computing resources around, maybe they're not even networking experts, they can actually plug in and use our products because they're affordable and cost effective, for the enterprise type customers, and they're also very high performance and precision. So let's get on to the topic of the webinar today that we want to talk about, which are moving applications to the cloud, from your own on-premises servers into the cloud. There are a couple of applications or a couple of options to do this. One is to rewrite a legacy application to function in parallel with the cloud application features. Another one is to replace that legacy application with SaaS, or software as a service equivalent. So essentially changing the application to a new application hosted by someone else. And then the third option is to migrate your application to the cloud environment. And that's going to be our focus here. It's kind of the most common and cost-effective approach. So in terms of implementing a migration, the thing most people look at to kind of reduce the risk and ensure success is, to move from a like-to-like computing environment. So you're going to look at the compute resources, the storage, the memory, the OS, and try and match that in the cloud service provider. So either moving physical to virtual or virtual to virtual, using the same OS in the target as you had in the source. And then most applications are going to be packaged up using standard tools, to perform in the virtual environment. So if you are trying to match, the computing environment one-to-one, so that you have less variables and less risk, the biggest change, though, in terms of the application is the WAN access, or the way your clients, your customers are going to be accessing that application. And that's where, the application performance may vary considerably, even though you have the same compute environment, because, they're going to be accessing that application via public or private, WAN links, and they have necessarily unpredictable performance characteristics. So why do applications, perform differently over the wide area? There are a couple of reasons. One is, many legacy applications are written in relation to LAN connections, so they expect the server to be, very close by on the LAN with a very small delay, less than 1 millisecond, and so there can be many interactions between the client and the server to do a simple function. So because it was designed a long time ago. Another reason is that transport protocols like TCP don't handle the impairments very well. So the impairments that you're going to get over the wide area network. And application throughput can actually drop really substantially. It drops like a rock when you have certain impairments. So TCP running on a 1 gigabit per second dedicated link, you can expect on a local area network to get, on a one gigabit link, 980 megabits per second throughput. So you're using the full bandwidth of that pipe. You add in some, delay, like 60 millisecond round trip delay, and that throughput can drop, 99%. It could drop down to like 11 megabits per second. And we're going to show you that in a demonstration later. And then if you add in a very small amount of packet loss, say 1 packet out of 1,000 gets lost, say over the wide area network, then your throughput can drop again to half that, to like 6 megabits per second. So even though there's a dedicated 1 gigabit pipe, WAN impairments can really hamper your application performance. So what steps can you take to validate the application performance in the cloud? A couple of things that we recommend are profiling, if you can, the real wide area network environment, or the connection between, say, your office and the server in the cloud. So if you can actually profile the real network and then set up a test network in your office or a lab to emulate those cloud conditions, and use a network emulator. You can then measure the application throughput and responsiveness by applying, different network conditions that you expect to encounter, based on your profiling. And we'll go through this in more detail. So, what ways can you actually profile your network performance? Well, there's a number of options out there. I just thought I'd touch on different options. Some of your service providers actually give you performance data, but generally they're averages, which are, average data metrics over long periods of time. So, average round trip times or packet loss, sometimes over, days or weeks or months. And so they don't really give you the worst conditions. Another source of performance data is, in the open source environment, you can find some tools that will give you average latency between big cities around the world, or even in the UK. Unfortunately, they're going to be limited to select cities, so they may not reflect your network or where your clients are sitting. Another option is to install a global network monitoring system that may give you more granular data on the actual network performance, but that may also be expensive and time-consuming to deploy and manage that. At Apposite, we actually have a utility tool that can allow you to profile network performance with a simple measurement system. We call it Network Recorder. and you can actually download that for free from our website, install it on any endpoint, and target a server IP address, and then it will record over time the network conditions, and primarily looking at the delay between those 2 points on the network and any packet loss. So you can record those conditions, save them into a file, and then move that file into your emulator and replay the actual live network conditions in the emulator, and then run your new applications across that emulator. So back to setting up that test network. You can actually install a network emulator between any two LAN segments, and then either run your real application or a test tool with test traffic across this test network to see how the performance is going to be. The server, you can use a real cloud server, or you could use your own server acting as the cloud server, and then the network emulator will simulate the variety of conditions that you're going to expect, and you can set up those conditions based on your profiling exercise. So what are these network impairments that I've been speaking about that are going to affect the application performance over the wide area network? Well, there's quite a lot of different impairments. The most common ones are bandwidth constraints, such that if you're sharing or if the client is sharing that access with many other clients, there may only be limited bandwidth available, and that may throttle the application throughput. The latency and jitter. So latency is the time it takes the packets to go from one point to the other, and then jitter is a variation in latency, which can also impact the application performance. Packet loss and bit errors are other common impairments. So even good networks, good carrier services, good managed services can experience packet loss when there's congestion in the network. And then we can actually create congestion as well to see how the network behaves. So congestion or even network dropouts, your application shouldn't hang, even if the network connectivity goes down for a couple of seconds because of something that happens out on the internet. Your application needs to be resilient enough to continue. So in the emulator, we mentioned that you can just set up your own bandwidth, delay, packet loss parameters yourself, or you can actually import that profile that we talked about and then run the application across the emulator. So here's some common settings on a simple emulator product. And we're going to show you a demo in a few minutes of that real traffic going over the emulated network. When you set up your test network, you can then monitor how the application traffic runs across the network emulator. You can do this on a single path, or you could do it over multiple paths, because you may want to create paths with different types of impairments. So the average network, the poor network, the good network, and maybe they represent different kinds of access technologies. So once you host that application in the cloud, you now want to know how it's going to behave with different access technologies, 4G, Wi-Fi, or shared access links, and then monitor application throughput in real time based on those access networks. Like how do those access networks affect your application? And then once you've got that test setup running, you can, as we said, run the real applications, or apply test traffic using tools such as iPerf between the clients and the cloud server, and that will enable you to validate the proper performance and quality of your application prior to the deployment. So rather than kind of talking about this and looking at bullets on a slide, we wanted to show you a real demonstration of this. And so to do that, I'm just going to pass the ball over to my colleague who has a demonstration ready to run, and his name is Court Buell. And let's see if I can do this in real time.
Okay, hi everybody. My name is Court Buell, and I will be running through the a demo here. Neil, thank you for the presentation there. So before I do anything, I just want to confirm, Sam, can you confirm if you can see my screen here?
Yeah, we can see your screen fine.
All right, perfect. Okay, so right here, what I have in front of me is this is our Netropy 10G2. This is the GUI. It's a browser-based GUI, and I think Neil showed you in the slides here, but right up top here, you can emulate multiple different paths with their own independent emulation parameters. And then this little pane down here, this shows throughput statistics, the RAID, number of frames, bytes. You can also, there's also an option to customize right here. And then you can also have an option to download the statistics into an Excel file. And then below here is the monitor. This will monitor, this will act like a stock ticker, monitoring overall throughput over a period of time. So what we'll do is right now is we'll go through, I'm going to run a basic test showing how the effects of impairments, what that does to overall throughput. So right up here, we have a link already established. It's called, we call it the Glasgow to London link. Right now I have bandwidth set at 100 megs. And right here is where you would set up your different parameters. So you set up parameters on each end of the link. So you can do, I just showed bandwidth. You can do background utilization, which is congestion. You can set emulate queue limits, queue strategy, also known as QoS, MTU limits, and framing overhead. And then in the middle here is the WAN in between, which you can emulate going in one direction and then also going in the other direction as well. So this is where up here you can set your delay. You do a constant, you can do a constant delay for your latency. You can also do it as a uniform, exponential, or normal, and this is a way to emulate jitter as well. And then you can also do emulate periodic network outages, packet corruption, packet reordering, and packet duplication as well. So what we're going to do is we're going to do a simple test right now. So I'm going to, we're going to basically have a 100 meg connection set up, no impairments whatsoever. And so I'm going to run request a quick FTP transfer. And so we see down here the ticker symbol. Right now we're getting almost full line rate right here. We're getting, and actually, one second here. I realize one thing that helps is if I turn emulation on. So we'll run that one more time. Okay, so here we go. Okay, so right now we're getting a full line right here, almost 100 megs per second. So we're going to go up here and we're going to put in some delay. So we'll do a constant delay. We'll do 50 milliseconds total round trip. So I'll put in 25 here for one way and then 25 the other way. Click apply changes. And so what's nice about this, you can make, as you can see, you can make changes on the fly. And then as you see the, you're starting to see a degradation in throughput right here. So then what we'll do is we'll up this. We'll do like, say, like 100 milliseconds round trip latency. And then you're going to see a dip right here. So we do it 100 milliseconds. All of a sudden, latency now goes, we're having to dip down to about 70 megabits per second. Now we're going to put in some packet loss as well. So we'll just do 1 out of 1,000. We'll do a random packet loss. We'll do 1 out of 1,000 every packets will be dropped. So 0.1%. Click apply. And then all of a sudden, like it totally drops. And I think actually this dropped because the file totally transferred, but so if we were to like reinitiate the file, as you can see, now you're only getting very little throughput. It's like choked down to almost 5 megabits per second, even lower than that. So as you can see, this is what the effects of latency, just even with latency and packet loss can do to the application throughput. And then up here, we're monitoring overall throughput, number of frames and bytes as well. So that's it for a quick demo. I'm going to, I guess, toss this back over to Neil.
Oh, thanks very much, Court. That was great. So just a few more words on emulation tools. I was asked a question about how do a professional tool like Apposite compare to some freeware that's out there. So there's some, over the years, there's some open source tools became available. One of the problems with the open source tools is they depend on PC hardware with different NIC cards that are very variable, so they're not the timing is not accurate at all. So what happens generally with freeware is people install it and then they get non-deterministic, non-repeatable results. So they might set a delay and then try and run their tests, but the delay is all over the place just because of the PC clock timing. Also, the freeware tools don't handle any kind of high capacity links, so the performance craters, when you start trying to go, above 100 megabits, for example. So they're quite unreliable. So you can't really save the results or share them around with people if you're using a tool that produces unreliable results. So that's kind of how we understand the freeware tools out there. Whereas most of our customers, when they talk to Apposite after they've been using the different WAN emulators, they basically said, I was up and running with tests in a few minutes, and I was able to get the results I needed. So that's a quick, comparison. Sam, was there any other questions from attendees?
Hi, Neil. Yeah, I've got one here. It says, what's the main difference between the Linktree and the Netropy ranges?
Sure, great. So the Linktree came first, and it was really designed for point-to-point WAN links, where you've essentially got a single link. The Netropy is the kind of second generation, and it provides more detailed network emulation where you've got multiple links with different impairments, and then you want to classify which traffic has which impairments. So we have something called a packet classifier, and say based on VLAN or based on IP address or TCP port number, you can then direct traffic down different paths with different impairments. So that's one of the main differences with the Apposite Netropy and Linktree. There are other features as well. So we can do replay packet captures like PCAP files. We can, as I said, easily import real network profiles into the Netropy as well. So essentially, there's more advanced features on the Netropy, and it goes up to higher speeds, like multiple 10 gig links, 40 gig links as well, whereas the Linktree is normally used for lower speed links up to gig.
Fantastic, thank you. And that leads in nicely to the next question, is how do you actually load in the recordings that you've got? I don't know whether you're able to show us that, Court.
Sure, I can show that. Yeah. Yeah. So to upload recordings, very easy. There's a two-step process. First thing you have to do is go to the administration tab here, and you have to actually load the recording itself into the system. It's basically, the recording is a simple text file. So you go to recordings, click add. Add a point to a file. You just click that to upload, and so then it's in the emulator, and then to apply it to a specific path, you would just go to the path. Actually, I'll turn emulation off. Go to the path, where it's click on the button for playback, and there you have like the list of playbacks you've uploaded, and then you just click that and apply. And you do that for both directions. And see, now you see like delay and loss are grayed out because you have they're being done by the recording now. And then you just turn emulation back on, and you can see the whatever the recording that had uploaded. You go.
Great, thank you very much. And is that feature available on all of the boxes?
Yes, yes, it's available for both Netropy and Linktropy. The mini version of our product does not have that option available, though, but all of our lab units do.
Perfect. I think that's all the questions we've got for the moment. So if anybody does have a question they'd like to ask, please just type that into the chat box now. So before we started the presentation, I asked Neil to select a number at random for our prize draw. And so we're pleased to announce that Andrew Pert from Enables IT has won the Mini G box. So Andrew will be in touch with you to arrange the delivery of that. Let me just have a look to see if we've got any final questions. No, that's everything. So Neil and Court, thank you very much for your time today. I hope people have found the presentation informative. We'll be uploading the recording to YouTube very soon.
Great, thanks very much.
Thank you.
Thank you.